impulse invariant. So previously in IIR filter, that's a classification. Previous video we discussed about um, approximate derivative, and now we are going to discuss about impulse invariant. So these are the steps to design a digital filter using impulse invariant method. So HAFS select sampling rate of digital filter. So express the analog filter transfer function as a function. Okay, the HAS summation of k is equal to 1 is 1 10 to m k s minus pk. So compute the Z transform digital filter using formula. So this is a formula, this is the steps I have to follow for impulse invariant method. So take it a first example for the analog function transfer function HA of s is equal to 2 divided by s plus 1 s plus 2, and we have to find it h is a transform at t is equal to 1 second and t is equal to 0.1 second using impulse invariance method. So HA of S is analog, H of Z is a digital system. So HA of S, so this is the value, and HA of S is equal to, so we have to split it into two. So A divided by S plus 1, B divided by S plus 2. So we have to find it what is A and what is B. So 2 A 2A S plus 2 and B S plus 1. So you will get the value like that, and put this S is equal to minus 2. If you put this S minus 2, then this is the value totally 0, then you get the value b minus 1, and you got the value b minus 2. And if you put s is equal to minus 1, then what is that? 2 is equal to a1 and a value is 2, so you got the value a is equal to 2 and b is equal to minus 2. So h of as is h of as is equal to, so a value you know that 2s plus 1 and b value minus 2 s plus 2. So we know that, so 1 minus s minus pk, that is 1 minus e power pk divided by 2 z inverse. So h of z is equal to, so 2 by, so we have to apply the formula 1 minus e power 1 by that 1 by t is at my z inverse, and this one is 2 by 1 minus z 2 by t 2t is at inverse. So we, from the question we know that t is equal to 1 second and t is equal to zero point 0.1 second. So first you apply for the t is equal to 1 second. So apply that and simplify the equation. So so if you apply that to t is equal to 1 second, then you got the value 1 minus 0.378 0.135 is at inverse. Okay, then so just to simplify the equation, and finally just you got it 0.465 z inverse and divided by 0.0496 z minus 2 minus 0.502 z inverse plus. Then in the problem they already gave t is equal to 1 and 1 second and t is equal to zero point 0.1 second. So t is equal to 1 second, we got the equation t is equal to zero point 0.1 second. Now apply the t is equal to zero point 0.1 second, then you got the equation. Okay, this is second example. This is equal to zero point 0.1. This is example, and this is a formula. We know the formula. Then we have to apply. This is similarly like the formula. Okay, so we just apply it, and in the problem they didn't give any kind of t value, so we just take it as t is equal to 1 second and simplify that part, and you will be get it h of z value. Okay. So this is another example. T is equal to 1 second they given. So use this formula. So this is a part look like s plus a squared b squared. This is a formula. So use the formula, and finally you will be get the value is h of z is equal to this is the value. Then on another example. So h of t values, and then okay, so this is another example they given, so you have to find like the first problem a and b. So a value and b value, so a value is 3.33, then b value is plus 3.33, apply it and simplify the equation, you got the digital system value. So actually this approximative this Impulse invariant is mainly used for convert the system to analog to digital. HAF is a analog and HF is a digital system. Okay, thank you.